Hello, welcome back again. Today we will talk about multi-table queries or join statements. Multi-table queries, as their name indicates, are queries that accesses data or extracts data from multiple tables. So basically we call them join statements because they simply join multiple tables, okay? That's their purpose. So an answer for this one is multi-table queries are queries that access information from the database by merging um, multiple tables. Multiple tables. It might be two, which is the default one, um, or more. Or sometimes it could also be one. We call it self-join. I will talk about that one later. But we will replicate one table into two virtually, and then query by merging this virtual representation and original representation of the table. So there are different uh, types of join, as you can see here. Inner join is the first type of join where data is extracted from the target tables whenever the condition is fully fulfilled. That means if you are performing inner join, then the tables on both sides of the join should fulfill the conditions you have specified, and that condition we call it join condition. Okay, so inner join is the first type of join. The second type of join, which is a bit opposite of this inner join, is outer join. There are three types of outer join, which are left outer join, right outer join, and full outer join. But in general, when we say outer join, then for candidate tables to be extracted in the result set, they do not necessarily have to fulfill all conditions which are specified on the join condition, but one of the tables in that candidate list should satisfy or should fulfill the condition. So there are three types, as I told you. The first one is, for instance, left outer join. So in the case of left outer join, um, the table on the left side of the left outer join will will be populated inside the result set, whether it fulfills the condition, the join condition, or not. So for in the case of, for instance, the join condition getting fulfilled for a specific tuple, then the table on the right on the left side with a tuple that's fulfilling this condition comes along with the table with the corresponding tuple on the other side. But in case if one of the tables do not fulfill this condition, then the one which does not fulfill the condition comes along with the one on the left side, in the case of left outer join, with null value. We'll see this one practically. The same is true right outer join, which will be on the right side priority. Full outer join, both side priority. Whether any table fulfills or not, its corresponding result comes with null or value, depending on the fulfillment of the condition. There is also another type of join, which we call it semi-join. Semi-join is kind of partial join. You can include it under outer join, where one part of the join candidates, which is either left or right, are emphasized more. There are also joins, we call them equi-join, join statements or multiple table statements that use equality operator to merge two or more tables into one and extract the result set. So here we will be using an online platform, cloud platform LiveSQL, which is provided by Oracle. We use specifically a schema provided by Oracle called HR schema. HR schema basically is a schema that holds tables and different database objects um, for human resource related activities. So we'll be working on this one. So before starting working on this experiment, which is about multi-table queries, we need to first clone some components, some tables or some database objects from the HR schema, because whenever we want to merge or access data from these tables, we do not need to qualify it with HR schema. We have to put it in our space. So this basically tables we are going to use today are available under HR user, so they are available under HR schema. So we need to clone them or copy them to our own working space. So for that, we could use a subquery, okay? We could use a subquery that allows us to easily copy the tables. So let's do this. Create table. The first table we'll be using here is employees. So employees is available under HR schema. So we do this. That's the first one. We create this one. The second one I will be using today is departments. Okay. The third one I will be using is locations. Okay. Yeah. The fourth one I will be using jobs is also very important. There is a separate table called jobs under HR schema. I'm copying it too. The fifth one is countries. Okay. The seventh one, you may not need all of this, but it's better to have them cloned. Is regions. Okay. Okay. Now I will run this one and create all these tables or clone all these tables from the corresponding HR schema. So these all tables are created now. We do have tables. So for instance, if I say select all from tabs, you will see list of tables which are owned by you now. So countries, departments, employees, jobs, locations, regions. These all tables are available now. In order to see what column in which table has, let me check with employees, for instance. So the command for that is desk or describe. So desk employees. So you can see employee ID, first name, last name, email is there. Here, for instance, we do have department ID. We call this department ID a foreign key because department ID belongs to departments table. So it's available here as a foreign attribute. Okay. So for instance, if I show you this one, desk department, then you can easily see department ID is here. When you go down, we do have location ID here. For instance, location ID is also a foreign key in this table. So there is interrelationship between these tables or entities. So if you describe locations table, for instance, which is a cloned table, then you'll see location ID is the first ID in locations table. Okay. And when you go down again, we do have country ID. We have created countries table, as you remember. So when you do this, desk countries, you will see country ID is there. So the same is true for regions. Okay, inside countries you will find regions, region ID, and if you desk regions like this, you will find region ID is a primary key under regions table. So this, what does it mean? This means all these tables are interrelated, right? All these tables are interrelated. So let me show you the syntax and experiments with some of the common types of joins. So the first join we have is inner join. I'll use the simple ASCII syntax to write join statement between any two tables in this table set. So let's come up with the syntax first for inner join. So different syntaxes could be applied, by the way. I will be showing you most of them today. So the first syntax, the simplest syntax we use will be based on alias. Okay, so we can say it's kind of ASCII type of syntax. So inner join is kind of equi join that extracts information whenever join conditions are fulfilled. So for that, let's see the syntax. So we do have select. Here we will have column or columns. This column or columns are extracted from any of those two tables we are going to join. Select column from, then table 1, okay, join table 2, okay. So for table 1 we can give alias. For instance, table 1 is say T1, okay, table 2 is T2. Then we'll use where condition, okay, where T1 dot join column join call is equal to T2 dot join call. This means this join call columns are supposed to be the same type of columns which exists in one table as a primary key and in another table as a foreign key, okay, or as a foreign attribute. So let me give you one application for you to apply this syntax. Report on the name and department, like we can say first name here, okay, first name and department name or name of employees in HR organization, okay. For this, we do know from our previous query, we do know first name is available under employees table, but department name cannot be found under employees table. So for that, we need multi-table, additional table, so which is departments table. So the only way to get departments is under department table or accessing department table. So for this, we need to merge first a table for first name and a table for department name, which are employees and departments respectively. But in order to join them, we need to have a common column in these two tables. And the common column in these two tables, as we have discussed before, is, we call it join column, okay? It's department ID. So let's execute the syntax we have written a couple of minutes ago. So we do this, select first name, we don't need last name, we are only asking for department name. So department name from, the first table is employees, let me call it E, join department, let me call it D, where the syntax allows us to do this, right? E dot, the common join table is department ID is equal to D dot department ID. So if you see this, department ID is a join column which is common to both tables, and we are requested to fetch or project data from two tables, which are first name from employees and department name from departments. So we are using the alias based or ASCII based command in order to do this. So let me run this one. I forgot something, right? Select first name, department name from employees E, join departments D, where E dot department ID is equal to D dot department ID. So that's the only thing I should do. I don't know why it's not working. Let me check again. Okay. Oh, okay. So the ASCII, right? We have been talking about ASCII, so I shouldn't be using this one. So unless I'm going to use on or using statements. So I think I'm supposed to do only this one, comma delimited one. Okay. I should correct this one. So select first name, department name from employees E comma departments D, where E dot department ID is equal to D dot depart. So let me correct this one. The syntax too. Okay. Join is not required here, right? This is the first, I'm I'm talking about the first syntax, which doesn't need the word join or the close join. So for that, I think this one should work. I'll get back to this syntax in a few minutes. So we do have first name and department name. So for the first name side, as you can see here, we do have first names from the employees table and department names from departments table. Okay. Okay, let me get back to the syntax I have been trying to write, which is the second syntax for inner join. You can also apply this one for other types of join. So join on. Join on is almost the same as what we did with this syntax, by the way, but uh, the syntax is different. The only difference is the syntax. So we have to replace the comma with join and the where with on, and you need this condition explicitly specified. Okay, like this. So we do have join between two tables on the condition. Okay, so let's do the same thing using join on. So I have to copy this one for ease of manipulation. Then here the comma will be replaced by what? Join, and the where will be replaced by on, right? Then this is the second syntax. So you can specify multiple on statements or conditions, join conditions, but this is the syntax. Join employees, join departments on this condition. Okay, when I run this one, you will get the same type of result as you can see here. The third syntax is join using, which is also the same, but the join condition part is different, because in join using, you only specify the join column. You do not specify the condition. So implicitly, in the case of join using, it's known that the equality operator or equi-join is going to be performed, or inner join is going to be performed. So in this case, you only say using and, okay, you can only specify the join column. So in this case, join call is our join column. So to change the previous syntax of join on to join using, you simply have to do using, and you simply have to delete all the other ones except for the join column, the common column. Okay, so here we have, as you can see, select first name, department name from employees, join departments using the join column. So if I run this one, you'll see the same result. And there are some conditions in which you do not really know what the join columns are. So in this case, you have to use a join condition called natural join. So do this whenever you do not know, okay, what the common column is or are. Okay, so let me show you the syntax. Select is there, column or columns is there, from table 1, okay, natural join table 2. It's as simple as this one. So what does it do? It extracts all common columns between these two tables and tries to join them with logical AND operations. So for some table to come to this result set, for some tuple to come to this result set, it has to satisfy all those join conditions specified by the natural join. So here, for instance, to do the same for this one, for instance, we can do select first name, department name from employees, natural join, see, departments. We don't need using, we don't need anything else. Okay, so here, let me run this one and you'll see the result will be a bit different from what we get with the previous queries. Let me run it first. Look, the first one was Steve, now we have Nina. Steve is not there, right? And there is a reason for that, because if you see the tables, employees, for instance, if you see employees, look, we do have the first common column is department ID. We know about this one. But if you go to departments, you will also see manager ID. Let me make sure that is available there. Okay. Manager ID is also available on departments table. You see? Here we have manager ID. So according to natural join, how it does is it will join, okay? The first one is employees, join departments using two tables. The first one is what? Manager ID, and the second one is a common one. We have been using this one, department ID. So in this case, the join conditions are where manager ID, the employees manager ID is equal to department's manager ID, and employees department ID is equal to department's department ID. This means the constraint, the condition, the join condition is a bit constrained or a bit hard to fulfill. So in this case, you know, it has some setbacks if you use natural join, but if you do not really know what the common elements are, it's really an ideal way to solve it. So in this case, as you can see, the result set is a bit different from the result set you get with join on or join using in the above examples, and it's mainly due to a more constrained situation imposed by natural join, and it's mainly also because of the availability of two join columns in these two tables, okay, in these two tables. So this is natural join. So we have been working on the same type of application, which is an application that requests us to report first name and department name of employees in an organization called HR, right? We have done this using the alias method, the ASCII method. We have done this using join on, we have done this using join using, and finally we have done this using natural join. Now let me give you another application that demands the application or execution of self-join. So self-join is a join with self, or a table, okay, joining with itself. This kind of join is required whenever the database designer misses to normalize the table, okay? Whenever there is data that should have been splitted into two different entities or tables but exist in the same table. So let me give you this one example. So you have employee's name, right? But what if you need the name of manager's name, their corresponding manager's name? So for this, for instance, the column looks like employee name, manager name. So you cannot get the manager name anywhere outside employee's name, because when you hire someone, you give them imp ID, right? And when they get promoted, then what happens? Their imp ID becomes their manager ID. This is a fact. This is the assumption for us to use self-join. So this cannot be acquired from departments table. This cannot be acquired from other tables except employees table. So select all from, let me show you this one, employees. So in order to get the name of employees and the name of managers, what you do manually is you see the employee is Stephen, which is first name, whose employee ID is 100. The employee is Nina, and her ID is 101. You go to Nina's manager table, okay? You go to Nina's manager table. I think this is manager table, the manager column, and Nina's manager is 100. And you get back to the employees table and search for 100 as an ID. So 100 is here. You get to the first name of 100, Stephen. So you infer the manager of Nina is Stephen. So a join condition or a join statement or a multi-table query that's able to do this kind of self-reference is called self-join. It's called self-join. Let's do this. So the query is already there. So let me formalize it. Report on the name, the employee name and manager name of HR organization. So for this, we do this. Select, okay, for the employee side, let's say first name, okay, and for the manager side, let me say m dot first name, okay. From the table is employees E, join again employees M. Okay, this is self-join. We are replicating the first table virtually. On, okay, the condition is here. On E dot, E is for employee, manager ID or D dot, M dot employee ID is equal to D dot manager ID. Let me put it down like this. So here we compare the manager's employee ID with the employee's manager ID. So that way we will be able to see what the first name of employees and their corresponding manager's first name. So let's do this. So you see, for Nina we have done, and we know Stephen is their manager, right? So for this, maybe let me use alias not to confuse you. So let me say this is alias, right? Employee name, and for this one let me say manager name. Let me rerun it. So employee name is Nina, manager name is Stephen. So this kind of join that requires a table to be replicated and queried for, you know, insightful report, we use self join, and it's a very important type of join. Okay, we have been working on, you know, inner join or equi join or similar types of join, where you have to fulfill all join conditions in order to have a result set. But in case of outer join, which is a join that doesn't really, it's kind of loose constraint based join, you do not really have to specify or satisfy the all conditions, the all join conditions. For instance, in the case of left join, T1 left outer join T2 means, this simply means tuples from T1 appears in the result set in any way, okay, in any way, whether they satisfy the condition or not. But tuples in T2 appears with value if they only, okay, let me make it like this, if they only satisfy the condition. Otherwise, as null, they appear as null. They appear as null. Okay, so the same is true for right outer join with like the same in a sense with a symmetry, you know. So tuples from, for instance, if you say T1 right outer join T2, then tuples from T2 appears in the result set in any way, but tuples in T1 appears with a value if they only satisfy the condition, otherwise as null. Okay, so in the case of full outer join, in the case of full outer join, um, look, this the syntax is also like this: full outer join T1, full outer join T2. Hmm? Then in this case, tuples from T1 appears in the result set in any way, but tuples in T1 appears with a value if they only satisfy the condition, otherwise with null. And also it's also true for left outer join. I will tell you this one succinctly. The same is true for this one. So what does this mean? Full outer join is equal to left outer join plus right outer join. Okay. So tuples from T1 appears in the result set. Tuples T2 appears with value if they only satisfy the condition, otherwise null. And it is also true for T2. Tuples in T2 appears in the result set in any way, okay? But tuples in T1 appears with value if they only satisfy the condition. They only satisfy the condition. So let me take the application we have been working on, and let's see whether there are tuples in one column which are not fetched because of the inner join we have applied. So let me start with left outer join. So we know the syntax now, but let me formalize again the syntax for the left outer join. Okay, so the syntax is select column or columns from table table 1 T1, let me call it T1, left outer join T2. Okay, then you can simply say like on T1 dot join column is equal to T2 dot join column. Okay. So this is this is the syntax for left outer join. Okay. So let me give you one application so that we will practice using this syntax. Okay. List the same query. List first name and last name. Sorry, department name of employees. That will be the first query. For the second query, yeah, okay. Let me do first the first query, and then we'll talk about the second query. So for this, with left outer join, select first name, department name from employees E, left outer join, departments D on, right? We need parentheses or not. It doesn't really matter. If you have multiple conditions, you may have to use this parentheses. Otherwise, you can leave it. So E dot department ID is equal to D dot department ID. So what does this mean? This means first name will appear whether it has corresponding department or not. Okay, first name may appear with the department name null if there is no tuple that satisfies the condition. This is what we call left outer join, because as you can see, employees is at the left side, so it will be prioritized. So its result, the result set will be fulfilled by all first names of employee, whether they satisfy the condition or not. Okay, so if you run this one, you will see. Okay, which table is that? Employees, departments, right? Here I missed S. Yeah, yeah. So here we have Jennifer with department and all other employees with departments actually. Hmm. Okay, all of them have departments actually. Let me switch this one so that we can see some null values. Huh? If there are any departments with no employees, so it's actually usually it is rare. Okay, this is also not the case. Actually, the query is right, but I want to show you null values because our query should prioritize the left side over the right side, right? Okay, sorry. Mm, okay, I will give you another example. Okay, I'll give you another example so that you'll see null values. Yeah. Okay. Okay. So let me do this one. Um, application 2. List the name and job title, okay, of employees. This is also a query request, right? Okay, query request. So for this, the job title, as you can see, is available under jobs table. Hmm? Different job titles are available under jobs table. So here we have job title, and if you see the table employees, you will see job title somewhere in this table, job ID somewhere in this table. So job ID will be a join column for these two tables, right? If you don't know the common columns, as I told you, you can still use what? Natural join, which will be an inner join. But in this case, we'll be using job ID for the outer join. So we are working on left outer join for now. So we do this. Select first name, sorry. Job ID is available under employees table, but we need job title, right? So for that, we call job title. Select first name, job title from employees E, left outer join, departments D, on the condition is E dot job ID is equal to D dot job ID. So when you run this one, if there are employees with no job ID, you will see no, actually our table should be jobs, right? Not departments, because we are merging it with jobs. So J is here. Job title only available under jobs table, so I have corrected it. Okay. So Steven is president, as you remember. Nina's supervisor is Steven, as you can see here. The job title of Nina is administration vice president. The only supervisor above vice president is president, so this makes sense, right? So everyone here has some sort of job title, right? Everyone here has some sort of job title. Yeah. But if we reverse the case, for instance, here let me put jobs J, and here let me put employees E. So if there are any jobs who do not have corresponding employees, we'll see null values, because this thing will prioritize uh, in this case the jobs over the department. So unfortunately we couldn't get data that conforms to our need, right, for this academic purpose. But it's better for you to check this kind of conditions, like tables which do not really have a one-to-one relationship in the schema, like jobs, countries, locations. We can go on and come up with this condition or situations that fulfills that. But from the syntax perspective, this is how you do left outer join, right? Right outer join, it's again the same. Let me go back to the syntax of left outer join and pull it down to right outer join. Okay, it's already there. So for right outer join, we do the same. Okay, the only thing we change is the name left to right, right? So we can run this one like this. So you can see the results. So the tables we are taking does not explicitly show the characteristics of left outer join or right outer join or full outer join, because they have one-to-one relationship. So every tuple in one table has a corresponding at least one tuple on the other table. So that is the situation. Okay. Okay. Yeah. Here it is. So left for the full outer join again. Let me copy this one. We have the syntax already. So we do this and full outer join like this. See? So full outer join for both conditions, it will fulfill. Yeah, yeah. So let me revise this one because I couldn't show you with the data. I can only show you with the application and syntax. So let me give you one example. So let's say we have table 1, and let's say we do have table 2. Okay. So for the table 1, let's say we do have A and B. For the table 2, we have say A and C. Okay. Then here, assume we do have values like 1, 2, 3. And here, let's say we do have values like A, some random values, okay? And let me go to this one. Let's say we do have 1, we do have 2, we have 3, or we have 4, okay? Here again, some random value again here. I'm gonna show you what left outer join, right outer join, and full outer join does to this query. So the application is going to be select B and C. So as you can see, B is available here, C is available here. So let me call it capital C. Okay. Now left outer join, what it does, it applies a join condition that says t1.a, right? t1.a is equal to t2.a. This is the join condition because the join column is A, the common column in both. So for this, okay, I shouldn't go down. So for this, how do the left outer join does? It takes A from T1, which is 1, checks for the corresponding value with this side, and displays it. So for the first one, we have 1 as a value. So B and C are required. So this both satisfies it. So small a and the columns required, sorry. The columns required are B and what is the other one? It's C, right? B and C. So for B we have value small a, right? For the other one, since it satisfies 1, there is corresponding 1 here. Its value is h, so we'll use h. Okay, that's the first one. Left outer join. This is basically what? This is basically T1 left outer join T2. Don't forget this. Okay. Okay. So for the second one, it goes to the second tuple. 2, does it have any corresponding here? Yes, 2 has another 2 in the A column of T2. So we join them. D and E are the corresponding values, right? D is here, E is here. Okay, for the third one, it checks 3. Here it has 3. Its corresponding B value is F. On the T2 side, does it have 3? No. So it only takes F because it prioritizes T1 since it is left outer join. T1 is on the left side. So it takes only F here. And on the right side, it provides you with null because there is no corresponding right table column or tuple. This is left outer join. That's all. The result you get looks like this one. Now let's do T1, okay, right outer join T2. In this case, it starts with the right table. So the tables we need, the columns we need are B and C, right? The application is the same. So from here, 1, 1. It has corresponding value, so the value will be AH. From the B side, there is A, right? From the C side, it's H, which is the same as the left outer join result for the first tuple. For the second one, we do have 2. We have 2, so D na E, D and E, okay? Then we use D and E here. For the third one, we have 4, right? But we do not have 4 here. So from the left side, from the B side, null will be fetched. But from the right side, T will be fetched, right? So B is null, okay? But D from the C side, it's T. You see the difference? On the left outer join side, the left table is prioritized because B belongs to left table. And in the right outer join side, right table is prioritized. This is, I think, clear. So T1, full outer join, T2 is the combination of these two. I said full outer join is equal to left outer join plus right outer join, right? So in this case, we can do and we can get both results concatenated here, B and C, right? Okay. So for the first one, let's start with the left outer join type of thing. So from the left side, we check 1 has corresponding tuple, so A and H will be fetched. Okay, the same thing we did for left outer join. For the second one, here, 2 has corresponding 1, so DE will be fetched. Okay. For the third one, 3 has corresponding element here? No. So 3 null will be fetched. This is a complete what? For the 3, F null will be fetched. So a complete left outer join is manifested here. Then it goes to the second table and perform right outer join. So from here, for 1, we have already acquired corresponding element during the left outer join, so it's redundant, it will eliminate. The same is true for 2, but for 4, it doesn't have corresponding element here, so it will take T from the C side and null from the other side. So it will do like this. T. Okay. So this is how the outer joins operate. It's pretty simple. Depending on the nature of the data, you can also practically see returning null values for some right table columns or tuples in the case of left outer join, and for some left tables tuple in the case of right outer join, and for both in the case of full outer join. The last join I will be showing you today is cross join, or we call it Cartesian product. Cross join is simply a join that concatenates or joins every tuple in one table with every other tuple in another table. So this is like if you have the same thing like columns A, B under table 1, okay, which has, let's say, values 1, 2. Then let's say we do have C and D in another table which has values 3 and 4. Okay, I don't want to fill the other values. Okay, then Cartesian product means, you know, for like the result is looks like A, B, C, and D. Then you'll have for every tuple in the table 1, you have to merge it with its null, right? We have the other one, which is 3 and some null value. Again, for 1, you have to merge it with this with the other one, 4 and some null value, right? So for like for the second one, again, we do have 2, right? For 2, you go to 3. Again, for 2, you go to 4. If you see, it's kind of mesh network. Every tuple in the first table are concatenated or merged with every other tuple in the other table. So this is called Cartesian product. How do we do that? Let's do Cartesian product between employees cross join with departments. Mind you, if you cross join employees with departments, or if you cross join it with a table which has n number of tuples and with another table with m number of tuples, then the result is n times m. Okay, the result of cross join result is n times m. So if you see n tuples and m tuples, for instance, okay, in this case the resulting table will have n times m tuple. So in order to do that, select, okay, whatever you want. Actually, you can say select all, select all from table employees, comma, departments. Okay, so if you run this one, you will see, you know, mesh type of thing. So for this, let me order it for you to see, to allow you to see the mesh characteristics. Order by employee ID. Look, in ascending order. So for every 100 employee ID, you will see a corresponding department information. Like for every 100, see here, department ID 10, department ID 20, 30, 40, 50, 70, 80, 90, 100, something, up to some department ID value, you will see. So here, if you check this one, for instance, the same department employee ID is available here. Again, for 101, the same thing. For 102, the same thing. Okay, this is called Cartesian product or cross join. Okay, so this is this is used, Cartesian product or cross join is usually used whenever you want to augment data or you want to multiply data so that you can mine important information from it. And sometimes it might happen due to query mistake. Okay, when you fail to specify join conditions, Cartesian product happens. So far we have been talking about multi-table queries or join statements. We have seen, or we have discussed about inner join, outer join, equi-join, semi-join. And from the syntax perspective, we have seen the ASCII syntax, the join on, join using conditions, natural join. And from the outer join side, we have seen full outer join, right outer join, left outer join. And also have seen cross join and self join, a special type of join. Whenever you have issues with the normalization of the table, you may have to use self join in order to get insightful information. That's all. Thank you for attending.